Which of the following statements are true? All right, we have this wacky looking graph here that doesn't make sense, and we are told that the limit as x approaches 0 of f of x equals the limit as x approaches 3 of f of x. Well, let's find out what each of those are. The limit as x approaches 0 of this picture appears to be 6. So you're 6. The limit as x approaches 3 of f of x appears to also be 6. So you are true. Let's take a look at that second one. The limit as x approaches 1 from the left appears to be 2. The limit as x approaches 8 from the right appears to be 2. So this guy is also correct. The limit as x approaches 5 is going to be 2. The limit as x approaches 8 from the left is going to be 5. So these guys are not true. So the ones that are true are going to be option 1 and option 2. Compute the limit as x approaches 2 of f of x, and we're given this piecewise function. F of x is the quantity x plus 1 squared for everything less than or equal to 2, and f of x is x plus 7 for everything bigger than 2. So since magic happens at 2, we need to make sure that the left-handed limit and the right-handed limit approach the same exact number, whatever that number is. Okay? If they do, then the limit exists at that number. Now, if that doesn't happen, and something like this happens where they approach different numbers, then that means the limit does not exist. So what we need to do is plug in 2 for both of these. So if we plug in 2 for this top one, we get 2 plus 1 squared, which is 3 squared, which is 9. All right, so this looks promising. If we plug in 2 for that bottom one, we get 2 plus 7, which is 9. So since both of these are the same exact number, that means these both approach at the same exact 9 whenever you have 2. So the limit does exist, and the limit does exist at 9 because they are the same from the left and the right. What was this? F of x, so we'll make that f of x equals 9, baby. If we know for a function f of x that f of 3 is 5, which of the following must be true in order for f of x to be continuous at x equals 3? Okay, well, if it's going to be continuous, then what we need is at some point, right, 3, 5, okay, we know that that's already the case. We need to make sure that the left-handed limit is also 5 and the right-handed limit is also 5. If that's not the case, then it's not going to be continuous. If even the left-handed and the right-handed limit are the same thing, that doesn't matter. They need to be 5. So if we know that that's the case, which of the following must be true? Well, the left-handed limit and the right-handed limit do have to be the same. So one is true. Also, if they are the same, that would mean that the regular limit is also going to be 5. So that makes 2 true as well. So if the left-handed limit is approaching 5 and the right-handed limit is approaching 5, that would mean that the regular limit is 5. That also has to be true. The limit as 5, or as x approaches 5, is 3, some point down here. Why would that matter? It doesn't matter, so not you. So the only two options that matter here are going to be 1 and 2, and those are going to be my guys, baby. A student attempted to prove that the function f of x equals 2x squared minus 9x plus 4 all over x squared minus x minus 12 was continuous at x equals 4. In which step, if any, does an error first appear? All right, so I have a feeling that this is not continuous and he's just going to find himself to be wrong. So let's see if he factored this out right. So 2x squared minus 9x plus 4, 2x minus 1, x minus 4. If I were to FOIL that out, I'd get 2x squared minus 8x minus 1x plus 4. So that checks out. This factors out to -4 and +3, so that checks out. So step 1 is just fine. Okay. Now, what he did is he then crossed that out, right? That's what it looks like he did. So he said that the limit as x approaches 4 of 2x minus 4 is 1. So that is a true statement, but that has nothing to do with it being continuous. So we're going to just kind of leave that be. Now what he is saying is f of 4 equals this function is 1. That is not true. F of 4 is the original function. Just because eventually you can cross these guys out doesn't mean you're allowed to just willy-nilly plug in 4 to this simplified version of it. This is an incorrect statement. So step 3 is where he screwed up. Step 3 is him saying, let's plug in 4 after I do a little bit of math, and that's not what you're supposed to do because f of x has changed. So this is wrong because if you were to plug 4 into the original function, you would get over 0, and this is not correct. So step 3 is his mistake. Step 3 is his mistake. Step 3 is his mistake, just like my mistake of not being able to draw circles. Problem's done.